Hi, Algebra 2. It's Mrs. Mack, and we are going to look at 4 examples today, see if we can put our trig ratios to work with SOHCAHTOA. Remember that. Sine is the opposite over hypotenuse. Cosine is the adjacent over hypotenuse. And tangent is the opposite over adjacent. And we can use that to find a missing side or a missing angle in a right triangle. Now remember that this only works in a right triangle. You have to have a 90-degree angle. So if I look at this triangle here, notice I know this angle 42 degrees. It is a right triangle. And then I know this side here, 16. This is opposite the 90-degree angle. So that's the hypotenuse. I know the hypotenuse. And I want to find this side x. That side x is opposite that 42-degree angle. So what trig function relates the opposite and the hypotenuse? Well, that would be our sine. So I can write an equation that the sine of 42 degrees is equal to that opposite side, which is x over 16. Now I have a nice equation that I can solve for x. I need to figure out the sine of 42 degrees. Unfortunately, we can do that on our calculator. There is one thing you have to keep in mind when you're using trig ratios. Anytime that you press the sine, cosine, and tangent buttons on your calculator, you need to make sure you're in the correct mode. So the mode key is right up here. I'm going to press mode. And if you can see right here, mine happens to be in radian mode. We will use that in a bit in this chapter. But right now, we know that that angle is 42 degrees. So I need to go down and I need to change that to degrees. So you need to make sure your calculator is in the correct mode. Once you do that, it is set. And you don't have to rechange it for each problem. So I'm going to figure out what the sine of 42 degrees is. I'm going to use 3 decimal places, but I'm going to let my calculator hold all the accuracy. But this is 0.669, and that's equal to x over 16. And now I can solve for x just by multiplying both sides of the equation by 16. So in my calculator, I'll just do times 16, that answer with all that accuracy, and x is equal to 10.706. Or you can round to 2 places if you like. I like 3 in there. So that would be the length of side x. Let's see if we can take a look at this triangle. We know 61 degrees. It's a right triangle. What sides do we have in relationship to this angle? Well, I have the opposite side, and I've got another leg, the adjacent side. So which trig function relates opposite and adjacent? That would be the tangent function. So the tangent of 61 degrees would be the opposite over the adjacent. Now I need to solve for x. It's a little tricky when you've got x in the denominator. And so I really just want to multiply both sides by x first to get x out of the denominator. And then I have x times the tangent of 61 degrees equals 10. Then I can put that in my calculator now, or I could just divide both sides by tangent of 61 degrees. So x is equal to 10 divided by tangent of 61, and I can do that on my calculator. 10 divided by the tangent of 61. It is still in degree mode. And I get 5.543. That would be that side length. Now go back and make sure that that makes sense. This was the longer leg across from the larger acute angle, so it would make sense that x would be less than that. If you get a number that just seems really wacky and strange, you either picked the wrong trig function or you're in the wrong mode. So it's a nice way to check that. All right, so that, hopefully you recall that from geometry. That's how we would find a missing side length. We can also use our trig ratios to find a missing angle. Here we've got that fancy Greek letter theta. I like theta. And so let's see, we've got 2 side lengths now. And I want to find that angle. Now we could use the Pythagorean theorem to find that missing side length, but we don't need to. That would just be extra work. I want to figure out what angle will this be if its adjacent leg is 14 and the hypotenuse is 23. Well, what trig function relates the adjacent and the hypotenuse? That is the cosine. So the cosine of theta would be equal to the adjacent 14 over the hypotenuse 23. Now, see if you can recall, how do you get an angle out of there? I have the cosine of that angle. This is like any function. To undo a function, you need its inverse. Inverses undo one another. And so there is the inverse cosine. It is cosine to the -1. Remember that -1 represents the inverse function. So you can take the inverse cosine of both sides. And the cosine inverse of cosine, that undoes one another. So those undo one another. And we're left with theta. And now on my calculator, there is the inverse function right above. It's in blue if you have an 84. It's in yellow, I believe, if you have an 83. And so to get to that, you're going to press the second key and then the cosine, and you can see you've got that -1. And in parentheses, I'll put 14 divided by 23. And this should come out to be an angle that is reasonable. Yes, 52.505 degrees is a reasonable angle. If you got something like 0.718, that would not be very reasonable, and that would probably mean you were in radian mode. Theta is an angle, so make sure you mark it with a degree marking. All right, and let's try one more. Here we're looking for an angle. It's a right triangle. And which sides do you have in relation to theta? You've got the opposite is 3 and the hypotenuse is 8. So opposite and hypotenuse, the sine function is opposite over hypotenuse. So actually write out your statement. This is important to write your equation. The sine of theta is the opposite over hypotenuse. Now to get theta by itself, take the inverse sine of both sides because the inverse sine undoes the sine function. And so those undo one another and theta pops out. And then the inverse sine is the second, then that sine function. Make sure you see that -1 there. So that's the inverse of 3/8. And we get 22.024. It's theta. It's a degree measure. That's a reasonable angle there. So we can use those 3 trig functions, sine, cosine, tangent, to write an equation, a relationship between an angle and its sides, and use those trig functions to find missing sides and missing angles. That should be a nice review for you from geometry. It should look somewhat familiar, and now you should be able to go ahead and work on that homework for today. Thanks so much.